Okay, good morning. Yes, the first problem, today's first problem, you write this, try to solve this one. Yashaswini, Yashaswini, switch on your microphone.
Yes, sir.
Yes, okay, yes, right. Just you tell me what is the data it is given here.
We have to calculate electron volt.
Okay, electron volt means what? Which is a measure of what? Electron volt is a unit, correct now?
Yes, sir.
What is to be determined?
The amount of energy associated with one atomic
Leave that.
mass
What is
unit.
to be determined? What
Energy.
energy? Energy. Energy. There are two units are there. Energy. There are two units are there. One is joule. The other one is electron volt.
Electron volt.
Joule is the SI unit. Energy. We are having the two units. One is joule. This is SI unit. The other one is your electron volt. This is not in SI unit. This is only the SI unit. There is a relation connecting between here and here. One EV is equal to 1.6 10 to the power minus 19 joules. From the lower classes, you have studied all these things. Okay, he says that atomic mass unit. Okay, Shaswini.
Yes, sir.
Okay. Don't switch it off. Let it be switched on, no problem. Okay, it is in terms of atomic mass unit is given. Do you aware of what do you mean by atomic mass unit? One atomic mass unit. Shall I write this one like this?
Yes, sir.
Somewhere else you have seen this one?
Yes, sir.
Where? Which class? First degree, second degree, final BSc, first PUC,
Second
second
degree,
PUC.
sir.
Second?
Degree.
Second degree. Where? Which topic? Atomic mass unit. So one atomic mass unit is equal to 1/12 of the mass of one carbon 12 atom. That is a definition. 1/12 of mass of one carbon 12 atom. Okay, 1/12 of taken from your second PUC. 1/12 of mass of one carbon 12 atom. Mass of one carbon 12 atom is the known thing. 1 by 12 is a definition. Definition for one atomic mass unit. This is a definition. So 1/12 mass of one carbon 12 atom is 12 divided by 6.023 10 to the power 26 kg. This is Avogadro number. 6.023 10 to the power of 26 atoms of carbon 12 weights is equal to, it weighs, is equal to 12 kg. 12 kg of carbon 12 it is containing this many number of atoms. Therefore, mass of one carbon 12 atom is this much. This value is equal to, if you are calculating this value, this is also taken from your second PUC. This, if you are doing the calculation here, you are going to get 1.66 10 to the power minus 27 kg. So this is a well-known thing. We have to remember this one as a degree student. Okay, any lower class student, if they are asking you, you are supposed to say directly 1 AMU is equal to 1.66 10 to the power minus 27 kg. This is atomic mass unit. This is in terms of kg. Both are mass. Both are said to be in terms of mass. Okay, clear. Now we want to convert this atomic mass unit in terms of energy. This is equal to, corresponding to this one, what is the amount of energy? So we know that energy is equal to E is equal to mc square. Now second PUC formula or degree, final degree formula. That is equal to, energy is equal to, mass is this, not 1 AMU. It must be in terms of kg. 1.66 10 to the power minus 27. Velocity of light is the known thing. You will get in terms of joules. If he is asking you calculate in terms of joules, you have to calculate this. You will get in terms of joules. But we know that one EV is equal to this many number of joules. We want to convert joules in the form of EV here. So how to convert the joules in the form of EV? 1.66 10 to the power minus 27, 3 into 10 to the power 8, that whole square, divided by 1.6 10 to the power minus 19. Now you will get in terms of electron volts, EV. Small e, capital V. Small letter E, capital letter V. EV. So do this calculation. Now, Vinay, what is the answer you got? How much is the answer you got it? Vinay or A? What? 9.33. Jilfi Joy, how much? Is it 9.33? Vinay? If you could not be able to write and show it, you can unmute and you can talk to me, no problem. 9:33 something. Yes, somebody has shown it. I don't know. Not seeing the name properly. Last person who has shown it. Microphone is not working, sir. Vinay. Okay, 9:33. Okay, you can type it. Point, decimal point, first decimal point, how much you are getting? Into 10 to the power 6. 7. Okay. Right. But this can also be written like this. Answer we got it already. But only thing is I will change a little bit here. In place of this, I will write capital M. Means million, million, mega, million. They are one and the same. EV. Million electron volt, million electron volt. This is in terms of electron volt. This is in terms of million electron volt. One capital M means 10 to the power 6. Okay, finished. Write the next question then. Question number 12. A 4 kg of a substance, if 4 kg of a substance is fully converted into energy, comma, how much energy is produced? Jilfi Joy, switch on your microphone.
Yes, sir.
Okay. Yes. Data you tell me. Okay, ma. Just you read this. What are the data are given? You tell me. I will write it here.
Mass equal to 4 kg.
Mass represented by which symbol?
M
Symbol.
W or
Mass. Mass.
M
Mass symbol. W for weight.
M
Mass
small
is different. Weight is different. Okay.
M sir
M. Small letter M. How much?
4 kg.
4 kg. Fully converted into energy, how much is the energy produced? What is to be determined?
Energy
Energy represented by,
E
he didn't mention EV or something. Therefore, conventional way that we are supposed to solve it. What is that? E is equal to mc square. C is the known thing now.
yes
You
sir.
know about that. C value 3 into 10 to the power 8 meter per second. Substitution, you do it. Do the calculation. So many joules. Unit is also important. Last unit, carefully had to write. Jilfi, what is the answer? Very simple question.
3.6 into 10 to the power of 17.
Thank you. Right. This is an answer. Hoping that you have written. Question number 12 is over. Question number 13. Write this. Calculate the ratio of the mass. Calculate the ratio of the mass of the electron to its rest mass when it is moving with a kinetic energy of 20 MeV, million electron volts. Rest mass energy of the electron, of course, given rest mass energy of the electron, rest mass energy of the electron equals 0.51 MeV. This is the question. Ratio of the mass of the electron to its rest mass is how much? Means mass of the electron divided by rest mass of the electron. Mass of the electron is m, rest mass of the electron is m naught, is equal to how much? That is to be determined. Okay, let us calculate. How much is the rest mass of the electron is given, rest mass energy, I'm sorry. Rest mass energy of the electron. Rest mass energy of the electron 0.51 MeV is given. How much is the kinetic energy of the electron? Means moving energy. Kinetic energy of the electron is equal to how much? 20 MeV. How much is the total energy? Is equal to 20 MeV. Be careful, if it is given in terms of kilo electron volts, you have to convert and then we have to add it. Here no problem, units are same. MeV and MeV, we can add it very easily. 20.51 MeV. Now, this is total energy. The total energy is mc square. Rest mass energy, I will write it here. This is m naught c square. Just I will take the ratio here. mc square divided by m naught c square is equal to how much? mc square is 20.51 MeV. This is 0.51 MeV. Get cancelled. C square get cancelled. Therefore, m divided by m naught is equal to Kiran Shetty. Answer it. How much you got?
40.2156.
40.2156. Not it over, Kiran. Unit is not mentioned. What unit I am supposed to write here?
Dimensionless.
Dimensionless. No unit. Mass divided by mass, energy divided by energy, get cancelled already. So it is a ratio. Therefore, no unit. If you are writing the unit, we are reducing the mark. So it has no unit. Right. Okay, go through this. Quickly finish it off. Next question. Calculate the rest energy of an electron in joules and in electron volts. And in electron volts. That's all he has asked the question. We know that what we are aware of that one. Rest energy we want to calculate. Rest mass of the electron, you are aware of that one. Rest mass of the electron. Kiran, answer it. How much is the rest mass of the electron? Rest mass of the electron. Rest mass
9.01 into 10 to the power negative 31 kgs.
9.1 10 to the power minus 31 kg. This is represented by which symbol, Kiran?
M to subscript E.
It is a rest mass. Don't forget, we are talking about the relativistic mass. One more mass is coming. While the electron is in motion, its mass is something else. While it is at
M naught.
rest, huh?
Sir, M naught.
Yeah, correct. M naught. Okay. But all these things that we are not going to discuss in the case of your second PUC portion. So no. There we are taking up rest mass, moving mass, they are one and the same. We are taking M is equal to 9.110 to the power of minus 31 kg. That's all we are going to say in the lower class. But in degree classes that we are saying, when the electron is at rest, it is having its mass. That is rest mass. When the electron is in motion, it is changing its mass, increasing. That is relativistic mass, because we are concentrating on the relativistic mass, because m is equal to m naught divided by root of 1 minus v square divided by c square. That formula is holds good. Therefore, as the velocity is changing, mass is also go on changing. As you are running more and more, if you are running with a high velocity, your mass is also go on increasing. Don't forget. Right? No, sir, because of running, my calorie is going to get decreased. Therefore, afterwards, my mass is, that is different. That is different. Okay. Right. If a rocket, if it is moving away from the earth, then there are so many problems that we are going to face it. So many problems. As the rocket velocity is more and more, then the rocket mass is also gone more and more, because the mass with respect to velocity is gone increasing. Right. So coming to the concept. Yes, we know that C is equal to how much? 3 into 10 to the power 8 meter per second. Use the formula E is equal to m naught c square. But he says we had to calculate in electron volt. M naught. You do the substitution, you will get in terms of joules. But I want to get in terms of EV, therefore same number divided by 1.6 10 to the power minus 19. Now you will get in terms of EV. Same number you have to put it divided by this, because conversion factor is 1.6 10 to the power of minus 19. EV is, 1 EV is equal to 1.6 10 to the power of minus 19 joules. Okay. 1 EV is equal to 1.6. This is the conversion factor. Subia Kausar, what is the answer you got? No answer from Subia. Sandhya, you answer it. Sandhya Rani.
81 point,
No.
81 point.
No, check it up. Kiran? I'm asking this. Oh, most probably you are answering this. This one again you have to do the substitution here divided by this.
Sir, 0.5118 mega electron volt.
0.5118, correct?
Yes, sir.
10 to the power 6 EV. That is equal to 0.511. 10 to the power of 6 can be removed and we can put a capital M here. Million electron volt. Million electron volt we can put. Is it correct, Sandhya, now?
Yes, sir.
Okay, madam. Write the next question then. Calculate the kinetic energy of an electron. Calculate Just wait for a minute. Searching for the sheets of paper. Question number 15. Calculate the kinetic energy an electron moving with a velocity of 0.98 times the velocity of light. In the laboratory frame. In the laboratory frame. Calculate the kinetic energy of an electron moving with a velocity of 0.98 times the velocity of light. Aishwarya Matthew. Yes, very good. Okay, ma'am. Just you tell me what is the data here. What is to be determined?
We have to find the kinetic energy of an
Oh,
electron.
okay, then
It is moving with a velocity of 0.9.
just a minute. Calculate the kinetic energy of an electron. Okay. Did you mention anything about in joules, in EV like that? No. Is
No,
it right? We can determine whichever that you want, either in terms of joules or in EV. Okay, leave it. Done.
its velocity is 0.
Shall I write V?
Yes, sir.
Okay. How much?
0.98
Huh?
c.
C. What is that C?
Velocity of light.
How much, madam?
3 into
Okay.
10 to the power of 8 meter per second.
Right. Good. Which is the constant formula we had to use it now? Data I have written. Now, which formula it is holds good here?
Uh, half mb square.
No, no. You are not in second PUC. Don't forget, you are in final BSc. I told you already. Okay. Directly half mv. Kinetic energy, half mv square, sir, you put it. Oh, it cannot be. Then why we had to study the Einstein's relativity idea? I told you already now, before this problem also. As the velocities go on changing, mass of the body is also go on changing. Therefore, correct? Aishwarya, is it correct?
Yes, sir.
Okay. Let us do the substitution and let us calculating. Not m naught. M is how much? In that velocity, if it is moving with this velocity, what is its? If it is moving with this velocity, what is the mass? Relativistic mass is how much? That is to be determined. Let us do the calculation. So m is equal to m naught. I don't know. I will keep it as it is. Otherwise, I had to substitute how much it is 9.1 something. We can substitute and we can calculate. No problem. We can. Okay. Let it be like that. Afterwards, we can do the calculation. Okay. Square root of 1 minus v 0.98 c, that square divided by this c, that is 3 into 10 to the c get cancelled now. Let me put c only here. Why I had to do the substitution again, cancelling that one. So that is equal to m naught divided by square root of 1 minus c square get cancelled, 0.98 square. Therefore, m is equal to, do the calculation. Aishwarya will answer that. Others, afterwards you can answer it. M naught, you keep it as it is. Sandhya, finished? Aishwarya, okay, right? Aishwarya, answer it.
0.199 m naught.
0.199 m naught, sure? M naught is right, but 1 divided by that, okay? Forgotten, I think it's so. 1 divided by this. Most probably you have calculated only denominator, but that is 1 divided by there. It is there.
Okay, sir. 5.025 m naught.
5 point.
025 m naught.
Okay, very good. Now it's right. Have understood what was the mistake? You have calculated denominator, but 1 divided by that we are supposed to do the calculation.
Yes, sir.
Right? Okay, small
Yes.
mistakes will be penalized like anything. So be careful. Carefully have to do all the calculations at the time of examinations. Right? Nobody will be there in front of you to say that one, okay, you made a mistake, you check it up like that. Okay, you have to do the practice. Now coming back to the concept. Now I want to calculate the kinetic energy. Is it right? This is the mass. This is the mass when it is moving. Okay, when it is not moving, this is the mass. When it is moving, this is the mass. When it is not moving, this is the mass. Now kinetic energy is equal to, okay, mc square moving mass minus rest mass. Moving mass minus rest mass. Rest mass energy, of course. So therefore, I can calculate here c square common factor. I can take it and I can do it here. So m is equal to how much? 5.02 m naught minus m naught, that's c square. So that is equal to how much you are going to get here? Here, 4 point something m naught into c square. 4.02. M naught is the known thing now. 9.1 10 to the power minus 31 kg. C is the known thing. 3 into 10 to the power 8 whole square. You will get in terms of joules. So calculate kinetic energy. You thought that kinetic energy is equal to half mv square. How doing that and keeping as it is? No, no. Aishwarya, answer. Kiran is showing the answer.
Sir,
Yeah, okay. Yes.
329.238 into 10 to the power of 15
10 to the power of
minus 15.
minus 15. 1 5.
329.238 into 10 to the power of minus 15.
Okay. Shall I write like this? Are they one and the same? Maybe decimal point may be changed. Right, Kiran? Okay, Kiran. Your question papers are already set for your IA. If I am conducting, if I am conducting the test, I will ask you to. Okay, what is that? You have to show the answer script, all of you, and you have to write like that. I will going to say that. If I am conducting, all right, the video must be kept open, and you have to show what you are writing. Okay, yes, right. Question number 15 is finished now. Question number 16. Shall I ask the different problems for your test? Not the work, whatever I worked out now. Okay, not that one. So just I will going to ask, shall I ask you, I am asking you, shall I ask you some different questions, different problems? No answer from your side? No, sir. Romana says no, sir. Sabha, no, sir. Why, Sabha? If you understood one question now, okay, let us see. Let us see. Okay, that's okay. That's okay. No problem. Okay, next question, you write it. Let me see. Next question. Question number 16. A particle of mass 10 to the power minus 24 kg is moving with a speed of 1.8 10 to the power 8 meter per second. Calculate its mass when it is in motion. When it is in motion. This is a question. You do it at home. You do it at home. I will give you one more problem here. Can't you solve this problem? You do it now. This problem, you do it now. Sabha says, no, 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 don't change any question. So now let me consider this itself is a small test for you. Whether you are going to solve this problem within the stipulated time, within 12:30. How many of you are going to solve this problem? Let us see that. First you write the question. First you write that question. This kind of problem already it has been finished. A pi meson has a mean life of 1.8 10 to the power of minus 6 seconds when measured at rest. How far does it go before decaying into another particle if its speed is 2.97 10 to the power of 8 meter per second? Hoping that you have written the question. Yes, solve it. Solve it now. I will solve it this side. Okay. Without showing to you, I will going to solve it. You also will solve it. Slowly I will solve that. Got the answer? Yes. Anybody who got the answer now? This is a question. Let's show the answer now. Along with you, I also solved that problem now. Now only I solved that problem. Yes. Dechama, how much is the answer? You got it? Alina, answer. Kiran, how much you got it? Vinay, answer. You type it. Romana, Stephen Matthew, Tobia Kauser. Answer, any one of you. Sabha, shall I show the answer now? Somebody has shown the answer now in the beginning. Who has? Okay, I will show the answer. Check it out. Whether you are getting the same answers or not, just to check it out. Consent formula. Substitution. Calculation, is it correct? Check it out. 12.75 something, 10 to the power of minus 6. Check it up whether the calculation part is right or